In question number 26, it says that the sound level of a point is increased by 30 dB. By what factor is the intensity of sound increased? So we know that the sound level increment, that means change in sound level, will be equal to the 10 log to the base 10 I1 by I2. This is the intensity ratio. So this is the formula of the loudness of sound level, right? So we know that if the loudness changes by delta beta, then the intensity ratio will be I1 by 2. So if I use this formula, according to the question, sound level of a point is increased by 30 dB. So delta dB is 30. This must be equal to 10 log 10 I1 by I2, right? So 0 0 will cancel out. So we can write I1 by I2 will be equal to, since if I take log towards left and here it is base 10, so we can say that in the right side it will become 10 to the power 3. That will be equal to 1000. So my option number 4 will be the correct choice. Let's move to the question number 27. In question 27, it says that select the correct option regarding stationary wave. So we know that in a stationary wave there will be nodes and antinodes. So let's say this is a node, and in between there is one more node. So how the stationary wave moves? So if all these particles are moving upward, then these all particles will be moving downward. So the wave will move like this, first like this, then after some time it will become like this, then after some time it will become like this, and then after some time it will become like this. So we can say that when these particles are moving downward, these particles are moving upward, and when these particles are moving upward, these particles are moving downward, right? So now let's read the options. Option 1 says all medium particles between two successive nodes oscillates in opposite phase. Between two successive nodes, as you can see that all the particles are coming down. So we can say that they are in same phase. So this is our wrong. Option number 2 says all medium particles in a loop on one side of a node oscillates in opposite phase with those of the particle in adjacent loop on the other side of the same node. So if this is the same node, so you can say that on the left hand side of this node all the particles are coming down, and in the right hand side all the particles are going up. So we can say that they are in opposite phase. So our option number 2 will be the correct. Now let's read the option number 3. Option number 3 says separation between two successive nodes is 2 lambda. No, we know that the separation between two successive nodes is lambda by 2. So this is also wrong. Option number 4 says separation between any two successive nodes is lambda. No, this is also wrong. So we can say that our option number 2 will be the correct choice. Now let's move to the question number 28. In question number 28, it says that a uniform rope of mass 0.1 kg and length 2.45 meter hangs from a ceiling. The time taken by a transverse wave to travel the full length of the rope is. So according to the question, a rope is hanging of mass 0.1 kg and length 2.45 meter. So let's say mu is the mass per unit length. If mu is the mass per unit length, right? So we know that the velocity at any point in a string will be given by root under T by mu in a string. So if I look at a distance x from the lower end, so the tension at this point will be the weight of this lower level, and weight of this will be how much? Mu into x into g, mg. Mu is the mass per unit length, x is the length, and g is the acceleration due to gravity. So this is the tension. So if I put the value, we will get velocity will be equal to root under xg. This is our velocity of the wave at this position. So we can write velocity as a dx by dt will be equal to square root of xg. So if I rearrange it, we can write dt will be equal to dx upon root x into root g. So if I integrate from 0 to t, 0 to L, we will get 2 root x by root g 0 to L. So if I put the values, we will get 2 root under L by g. This is the time taken by the wave to travel from bottom to top, and the length is given as 2.45 meters. So if I put the value, g is 9.8. So if I put the value, we will get 2 root under 2.45 divided by 9.8. So that will give you 1 second. So my option number 4 will be the correct choice. Now let's move to the question number 29. In question number 29 it says that a 1.5 meter long rope is stretched between two supports with a tension that makes the speed of transverse wave 48 meter per second. Wavelength of second overtone is. So we know that when a string is stretched between two supports, then the frequency of vibration will be given by NV by 12, right? So for the second overtone, N should be equal to how much? 3. So we can write 3V by 12. But what we have to calculate? We have to calculate the wavelength. So we know that wavelength can be written as velocity by frequency. So we can write 2L by 3. And the length is given as 1.5 meters. So we can write 2 into 1.5 divided by 3. That will give you 1 meter. So my option number 1 will be the correct choice. Now let's move to the question number 30. In question number 30 it says that which of the following graph is correct? So graph is drawn between speed of sound and temperature in Kelvin, or temperature in degrees centigrade, temperature in degrees centigrade, temperature in Kelvin. But we know that the speed of sound will be equal to root under gamma R T by M, where gamma is the Cp by Cv, that is atomicity for any gas. So if I square both sides, we will get velocity of the sound square will be equal to gamma R by M into T. And since here T is always in Kelvin, T is the absolute temperature, so it should always be in Kelvin, right? So we can say that the velocity square will be directly proportional to the temperature, where the proportionality constant will be equal to gamma R by M. So the graph will be straight line passing through origin, right? So we can say that our option number 1 will be the correct choice, right? Yes. So my option number 1 will be the correct choice. Now let's move to the question number 31.